This example is taken from the 2017 to 2018 paper. So if we look at this example, we have a square root. The larger function is contained within the square root. So the first thing we have to do is rewrite it using indices. So that is 1 going from the upper limit of 1 to the lower limit of 0 of x squared minus 1 times x cubed minus 3x plus 2, and the square root is replaced by the power of a half times dx. So then we're able to follow our normal procedure. We let f of x equal to the larger function, so it's x cubed minus 3x plus 2, and g of x is the other function, x squared minus 1. The first step is to differentiate f of x, so f prime x is equal to 3x squared minus 3. To find the constant a, I divide the coefficient, we have x squared in both terms, so I divide the coefficient of x squared in g of x here, which happens to be 1, and I'll divide that by the coefficient of x squared in f prime x in the first derivative. So that gives me a is equal to 1 divided by 3. So the question then is a times f prime x, a times the first derivative, equal to the second function in the product, g of x? So a is 1/3 times f prime x, that's x squared minus 3, and if I multiply that out, I get x squared minus 1, and that in fact is equal to g of x, so the answer is yes. So that means, once that's the case, that means we can use our rule, and once again I'll write out the rule again. A times f prime x times f of x to the power of n dx is equal to a times f of x to the power of n plus 1, so you raise the power by 1 and you divide by the raised power. So if we apply that to our problem here, we have the power is a half, so we have 1/3 times 3x squared minus 3, and then our function is x cubed minus 3x plus 2 dx. So if I write that out, that's our f prime x, our first derivative, and this is f at x. And we can apply our rule then, so we can say a is 1/3, and we have f at x, which is x cubed minus 3x plus 2. Our power was a half. I should have put the half in here. So of course, if we have a half and we add 1 to it, we're getting 3/2. So the new power, the raised power, is 3/2, and we divide by the raised power, which is 3/2, and they go between the limits from, our upper limit is 1 to 0. So here we're going from 1 to 0, and here, sorry, I'll put a bit of color coding in here just to differentiate. Here we're going from 1 to 0. So if I bring it down here, first of all, before I do that, I will take our 2/3 here and rewrite it. So it's 1/3 multiplied by 2/3. So 1/3/2 is the same as 2/3 times x squared minus 3x plus 2 to the power of 3/2. And that's going from 1 to 0. So if I keep going here, that gives me 2/9. And then I'm going to rewrite this, so it's 3 times a half, x squared minus 3x plus 2. So it's 3 to the power of a half. So I'm going to rewrite, before I evaluate it, I'm going to turn it back into a rational number, into a square root. And that gives me 2/9 times, the half here tells me it's the square root, and I have x squared minus 3x plus 2, and I'm going to cube that lot. And that's going to go from 1 to 0. So now eventually I'm in a position where I'm going to plug those values in. So it's giving me 2/9 times the square root of, so I'll just put the constants in, minus the square root of minus 3 plus 2. So you see I'm just putting the constants in first. That's cubed, that's cubed. So if I put the upper limit in, it's 1 squared minus 3 times 1 plus 2. And if I put the lower limit in, it's 0 squared minus 3 times 0 plus 2 cubed. So if I evaluate these terms, I have 2/9 times the square root of 1 minus 3 plus 2 is all 0 to be cubed. So in fact that evaluates to 0 when you work it out. Minus, and over here that goes to 0, that goes to 0, that goes to 0. So we're just left with 2 cubed, which is the square root of 8. So if we evaluate this, we have minus 2 times 9 times the square root of 8. And if we can split that into 2, minus 2 times 9, so that's the square root of 2 times 4. And this gives us minus 2/9 times the root 2 times the root of 4. Of course, the root of 4 is equal to 2. So it gives me minus 4 times root 2 over 9. If I evaluate this, it gives me minus 5.657 divided by 9. And that gives me minus 0.628. Okay, so that is my final answer. It's minus 0.628.